This is LLC converter with a buck boost operation. In this, the input voltage is around 300 volt and the output voltage it is varied from 15 to 30 volt. We are using half bridge LLC resonant converter to get the required operation, and we are using the fuzzy controller. Here this is the reference voltage. Initially it was 15 volt, and after that, after zero point 0.1 second it is 30 volt, and it is given the feedback voltage from the load is taken and given to the control circuit, and it is converted to per unit error. The per unit error is given to the fuzzy controller. The fuzzy controller will convert the error to duty ratio according to the rules, and that duty ratio is given for pulse generation, and generated pulses is given to the MOSFETs of the LLC converter, half bridge LLC converter. And here the secondary part is given to the rectifier, and the rectifier output is given to the load. Here this is the input voltage, current and power. Input voltage is 300, current is around 0.04 amps, and power is around 15 watt to 30 watt. And this is the load voltage. Initially it was 15 volt. After zero point 0.1 second it is increased to 30 volt according to the reference voltage. Similarly, the current is around zero point 0.5 amps to 1 amps, and the power is around 8 watts to 30 watts. We are getting the power, load power, and this is the efficiency of the converter. For lower voltages, the efficiency is around 55 percentage. For increased voltage, that is when it is stepped up, here we are getting 94 percentage. If we increase the voltage further, we can get the higher efficiencies in this resonant half bridge LLC converter. Here we are using fuzzy to improve the efficiency and also accuracy, settling time, those things. This is a simple working of a resonant LLC converter with fuzzy control. In order to run the fuzzy control, you have to type fuzzy in the command window. A dialog box will open. You have already created the FIS file, that is fuzzy interference system. So that file we have to access. Here, this is the file, and we have to provide it, export it to workspace. Okay. Here if you see, these are the inputs and outputs for the fuzzy control. Input range from negative very large to positive very large, because the error is can be of negative or positive any value. So if it is in negative, that means the measured voltage is higher than the reference voltage. If it is positive, the measured voltage is lower than the reference voltage. According to that, the output should be selected. Output ranges from 0 to positive large because it is the duty ratio. So these are the inputs and outputs given to the fuzzy control and rules. That is when the input is, that is the error is negative means the output is 0. When the input goes to positive, then only the output duty ratio is increased to positive. When the input difference is higher in positive, then the duty ratio should be higher. So these are the rules we are setting for the fuzzy controller in order to get the results.